Okay, we are going to continue with Unit 5. These are properties within a triangle. So 5.4 is using medians and altitudes. So what is a median? So a median of a triangle is a segment that connects one vertex of a triangle and the midpoint of the side opposite that vertex. Okay, so if I draw a triangle over here, let's say I'm going to put, this is just a guess, I should be more accurate by using a ruler, but I'm going to say that's the midpoint, and I know that's the midpoint because I said that that's equal to that, right? So the median connects the midpoint of the triangle to the vertice that is across from it. So right there, that's not the best line. Okay, so that is a median. Okay, so in a triangle we would have three medians because we have three vertices, three sides that would have a midpoint. So here's a median, here's a median, here's a median. This piece is equal to this is equal to this is equal to this. They all connect at this point P. That is a point of concurrency. Remember, a point of concurrency is a point in which three or more segments meet and intersect. Okay? So Theorem 5.8 talks about the concurrency of medians in a triangle. Well, what this is saying is the three medians meet at a point whose distances have a ratio of 1 to 2 for the segment. That may not make a lot of sense, and I probably did not word that the best, but what this is saying is, okay, so I have this median B to F. It has this point P on it because that is the point of concurrency of the medians. Which is actually called the centroid. So this point is called the centroid. This centroid splits this segment in a ratio of 1 to 2, meaning this piece, let's say if it was 5, P to F is 5, that would make B to P 10 because it's a ratio of 1 to 2. For every 1 unit here, I have 2 units here. Okay? So 1 unit, 2 units. Another way to think about this is that the centroid splits this entire segment into 1/3 of the distance and 2/3 of the distance. So this whole distance is 15. 5 plus 10 is 15. Well, 1/3 of 15 is 5, so that's that smaller segment. 2/3 of 15 is 10. That's that bigger segment. Let's say D to C is 18. So the entire distance D to C is 18. Well, we have D to P and P to C that make up that 18. Looking at this, D to P from the midpoint to the centroid is my 1/3 segment. P to C is my 2/3 segment. So if the whole distance is 18, 1/3 of 18 is what? So what goes into 18 3 times? So take 18 divided by 3 and I get 6. So 1/3 of 18 is 6, so D to P would be 6. 2/3 would be taking 2 of those, so 6 times 2, which is 12. If you notice, the smaller section is always half the bigger section. Okay? Centroid, we just said, was the point of concurrency of medians in a triangle. Okay? So in this section we're going to talk about two different things. We're going to talk about medians and their point of concurrency, which is the centroid, and then we're also going to talk about altitudes. So what an altitude is of a triangle, and again we're going to have 3 altitudes in a triangle, but an altitude is a perpendicular, that's the symbol for perpendicular, segment connecting one vertex of a triangle and the side opposite. So if I were to draw this triangle, just a triangle, I'm going to connect this vertice to this side, but at a 90-degree angle. So I'm going to go straight down to hit that at a 90-degree angle. Okay? In a triangle, I will have 3 centroids. Okay? And those 3 centroids will hit at a point. And depending on what kind of triangle it is, it could hit inside the triangle, on the triangle, or outside the triangle like this one does. Okay? So theorem 5.9 states that the 3 altitudes are concurrent, meaning they will intersect. Concurrent. They will intersect at some point together. Okay? The point of intersection of those 3 altitudes is called the orthocenter. So that's the point of concurrency of these 3 altitudes. Here's a acute triangle. Okay, they intersect at a point of concurrency that's inside the triangle. On a right triangle, they actually intersect down at this point, so on the triangle. And then an obtuse triangle, they intersect at a point that's outside. Okay, outside, inside, and on. They match up with the centroid or circumcenter. So if you remember back to 5.2, that was circumcenter. That was the perpendicular bisectors. Perpendicular bisectors intersect at a point of concurrency that we call the circumcenter. The circumcenter follows the same rules. On an acute triangle, it's the inside of the triangle where they meet. On a right triangle, it is on the triangle. And an obtuse triangle, they meet outside the triangle. Okay? So G is the centroid of this triangle over here. Okay, so it is the centroid. So we got to look back up here to centroid. So it's the point of concurrency of 3 medians. Okay? So that means that this piece equals this piece equals this piece, and then this piece equals this piece. And then the centroid itself splits the segment into a 1/3 and 2/3 section. Okay? So what I want you to do is I want you to take this information of what they give you, the picture, and I want you to find 1 through 6. Go ahead and pause me. Try those on your own. Unpause me when you are done. Okay, so B to D, they want the length of B to D. Well, B to D was B equal to A to D since this is a midpoint, because that's the definition of a median. It hits at the midpoint, so that would be 8. A to B, so that's the whole way would be 16, the 8 and the 8. E to G, okay, well they gave us that A to G is 10. If you remember, my 1/3 section and my 2/3 section, my 1/3 is half of my 2/3, so half of 10 would be that 5. A to E all the way across, so that would be 10 plus that 5, which is 15. C to G is my bigger piece. That is my 2/3 section. They don't have anything labeled, so let's look up here. They tell me that A to G is 10. They tell me that C to D is 18, so the whole distance is 18. Well, C to G is my 2/3, so I'm going to take 18. I want 2/3 of 18. Remember, in math, of means to multiply. So 18 times 2 is 36. 36 divided by 3 is, is 12. So my 2/3 section would be 12. And then that would allow me to be able to find my 1/3 section by either taking the whole distance, 18, and subtracting off the 12 that we already found, or taking 18 and finding 1/3 of that, which is 6 in both cases. All right, next page. Find all the midpoints of each side of J to K to L. All right, so midpoints. You need midpoint formula, right? Midpoint formula is take your x's, add them, divide by 2, and then take your y's, add them, divide by 2. It's just like finding an average, right? So J to L. So I'm going to take my x's, which is -2, and add 2 to that, divided by 2. That's for my x. Take my y's, which are 7 plus -5, and divide by 2. So -2 plus 2 is 0. 0 divided by 2 is just 0. That would be 2 divided by 2, which is 1. So the midpoint of this is at 0, 1, which there is a point right there. Okay. Now we have L to K. Same kind of process. Add your x's, so 6 plus 2 divided by 2. Add your y's, y plus -5 divided by 2. That would equal 6 plus 2 is 8, divided by 2 is 4. 1 plus negative 5 is negative 4, divided by 2 is negative 2. So over 2, 4, down 2. Because if you notice, this coordinate grid is going by 2s and not 1s, so be careful on that. And then the last one we need to find is j to k. So again, my x's, negative 2 plus 6 divided by 2, and 7 plus 1 divided by 2. Negative 2 plus 6 is 4, 4 divided by 2 is 2, and then that's 8 divided by 2 is 4. Okay, so I'm going to put that point in. That is j to k, that's at 2, 4, right here. Okay, so I'm just going to do a quick sketch of my center, or my median. So it goes from the vertice to the side opposite, vertice to the side opposite. Okay, so here's my centroid. It is meeting at that point, and this one's nice because it's directly on a number. It is on over 2 up 1. Another way to actually do that mathematically is, okay, from here to here, I'm going to find the distance of that. That is a distance of 2, 4, 6. So this midpoint we'll just call M. So M to K is a distance of 6 units. Well, M to the centroid here is 1/3 of that. So if I take 1/3 of 6, that would be 2 units. So from this point, from M, which we set up here was at 0, 1, I need to go to the right 2 units. So if I'm starting at 0, 1 and I go to the right 2 units, that would be my x. I'm going to add 2 to my x, so that would be at 2, 1, which is what we got over here. Okay, is BD a perpendicular bisector of A to B to C? Is it a median or is it an altitude? So perpendicular bisector cuts it in half at a 90-degree angle, so that would be this guy. But it could be multiple things. Could it be a median? Well, the definition, remember, of a median starts at the vertice, goes to the opposite side at the midpoint. And that one does that. So this one is also a median. Let's see if it's also an altitude. Remember, the altitude goes from the vertice to the opposite side at a 90-degree angle. And that's what this guy does too. So this is actually all 3. Is this a perpendicular bisector? Well, for it to be a perpendicular bisector, it has to go to the other side at the midpoint, and that for sure does not do it. Is it a median? So median cuts it in half. It doesn't do that. And is it an altitude? Vertice to the opposite side. The 90-degree angle has to be at the opposite side, not this side. So they put the 90-degree in the wrong place. So this is none of the above. This guy, perpendicular? No, it's not hitting a 90-degree angle. Is it a median? Goes from the vertice to the opposite side midpoint, so it is a median. And is it an altitude? It has to hit the other side at a 90 degree, and it does not, so it is not that either. Complete the statement for triangle HJK with medians. Okay, so let's draw this. HJK. Medians H to N. J to L, and K to M. There is no way you could do this problem without a picture, so you need to make sure that you're drawing a picture on this and on a lot of your problems. That's the whole thing about geometry, guys, is that we need pictures all of the time, so make sure you're putting those pictures on. Okay, so P is the point of intersection of the centroid. P to N is equal to H to N. So this piece is equal to that whole piece. So what would I have to do to P or H to N to get P to N? Well, P to N is the 1/3, so I'd have to multiply it by 1/3. P to L is the 1/3, and they want to know for J to P. So what do I have to do to J to P to get P to L? Well, I'd have to divide it by 2 or multiply it by 1/2. Because P to L is half of J to P, so to get J to P back down to P to L, we'd have to multiply by 1/2. K to P is my 2/3 section. They want to know what I need to do to K to M, my whole piece, to get my 2/3 section, so I multiply by 2/3. Okay, you are going to have a second video over the rest of the notes. Just make sure you watch those and take the rest of the videos.